we stopped last time on the energy stores, right? So today, inshallah, we're gonna take the lesson 2 or P2, energy transfers by heating. So first, we're gonna define the thermal conductivity. We have many types of material. We have conductor and semiconductor and insulator. Conductor, the material that connect the heat or electricity. Semiconductor in between. Insulator, the material that cannot connect the electricity or has a very low thermal conductivity. So we're going to start with the definition of thermal conductivity of material. The thermal conductivity of any material tells us how quickly energy is transferred through the thermal conduction. So if you have a rod like this, the amount of energy transferred from one side to another side give you the amount of thermal conductivity. So you can do experiment to check the thermal conductivity of many materials by having 3 different rods. As you see here, you have 3 different rods made of different materials, like one of copper and one of aluminum, one of iron, and heat and wax in the one of the ends of these rods, and making heating to the other side after time. So the wax start to be melt, and the higher the thermal conductivity of the metal, the melting of the wax will be faster. So this experiment is very simple, because when you heat one side of the rod, the heat will transfer from one side to another until reaching to the other end, and the wax starts to be melted. So the faster the melting, the faster the thermal conductivity of the material. So you can test the thermal conductivity of rods made of different materials using this experiment setup. Each rod must have the same diameter. So we have many factors affect the thermal conductivity. The diameter of the material or of the rod affect the thermal conductivity. The length of the rod affect the thermal conductivity. The difference in temperature affect the thermal conductivity. So to do the experiment, and if you need to check the thermal conductivity alone, you have to make all other factors constant. So the 3 rods should have the same diameter, same length, and same temperature difference between its ends. So one end of each rod is covered in wax, and the other end are heated equally. So they have the same diameter, the same length, and the same temperature difference between their ends. So after that, the faster the wax melts, the higher the thermal conductivity of the metals. So the application of thermal conductivity is insulating buildings. Heating buildings can be very expensive, because some of the building, once you start the heating, the heating lose from the building very fast. So we need to have a building with low thermal conductivity. So if the thermal conductivity of the walls and roof are very small, so the amount of heat transfer will be very small. So we're gonna keep the temperature inside the building, and we're gonna save the electricity. So some factors that affect the rate of heat loss from building include: number 1, the thickness of its walls and roof, the thickness. Number 2, the thermal conductivity of its wall and roof. Lower thermal conductivity, lower rate of heat loss. So we need building with low thermal conductivity. The thermal conductivity of the walls and roof can be reduced using thermal insulators. So insulators is insulators are opposite to conductors. So thermal insulator is a material which has low thermal conductivity, and the rate of energy transfer through the insulator is very, very low. So now we're gonna see how the energy transfer per second through a materials and what factors affect the energy transfer. The first factor is the thermal conductivity. So energy transfer from one through the material affected by the thermal conductivity. Number two, the temperature difference between two sides of the material. Number three, the thickness of the material. So if we go here, if we have rod like this, you see my OneNote file?
Okay.
Yes or no? Let me make sure you are seeing my note file.
Yes, we see it.
Hello?
We see it.
I can't hear your voices. Are you seeing my OneNote file? Yes.
Yeah.
Yes.
My voice is
Yeah,
good.
we
As
see.
I'm saying, yeah, I am lagging. My voice is good?
Yeah.
Okay, Adam, thank you. So if we have material like this and we need to transfer energy or thermal energy from one side to another, so the energy transfer should be dependent on the thermal conductivity of this material, thermal conductivity, and the thickness of this material, and also the change in temperature, d theta. Some reference taking dt, change in temperature. So if I have one rod of iron and another rod, the same rod, of, for example, copper. So if they have the same thickness and the same energy, temperature difference, the amount of energy transfer will be different. Do you know why? Because the thermal conductivity of the iron material is different from the thermal conductivity from the copper material. If I have two iron materials, they have the same thermal conductivity, and I'm gonna heat them with the same temperature difference. But if their thickness are different, so I'm gonna have different energy transfer. So the energy transfer depends on thermal conductivity, thickness, and the change of temperature. Okay. So now we're gonna take the specific heat capacity. For each material or substance is heated or cooled, the temperature change depends on the substance mass and the type of material and how much energy is transferred. So you have to differentiate between the amount of energy transfer per second through a material and the change in temperature in a substance. Change in temperature depends on the substance's mass, type of material, how much energy is transferred. And this is make for every material or every substance has its own specific heat capacity. Specific heat capacity, by definition, the amount of energy needed to raise the temperature of 1 kilogram of substance by 1 Celsius. So if I have one of the substance like or material like iron and make heating over here, for example, start with 10 Celsius and I heated it to 25 Celsius. The change in temperature here depends on, number one, the mass of this material. Number two, the amount of heat transfer. amount of heat energy transfer. And number 3, the amount of heat transfers and the thermal amount of heat transfer and mass. And number 3 is the type of material. Yes, the type of material. So the specific heat capacity, I need to choose the same symbol as you have. It's delta E, MC, delta C. Okay. So delta E equal MC d theta. This is the equation we have to know. Okay, so delta E is the amount of energy. M is the mass. C is the specific heat capacity. Delta theta change in temperature. You can use delta theta or delta T, the same. Guys, who gonna give me the specific heat capacity in one side and all terms in the other side? Who can rearrange this equation? Can you type in chat, please? Can you rearrange this equation and give me the value of the specific heat capacity? You don't really understand. I need C. Okay. This is the equation of specific heat capacity, right? E equal MC d theta. I need C equal how much, and I need d theta equal how much. Can you solve this for me, please? Salma, Nada, Jana, Bisan. Once you do this, I'm gonna tell you why I'm asking for the rearranging the equation. So 1 minute, type your answer in chat, please. I need C and I need also d theta. Okay. So Anas, Osama, Nada. Okay. Can you send the answer privately to me, please? Don't send your answer to everyone. Okay, for C equal E divided by M delta theta. Just divided by M for the both sides and divided by delta theta for the both sides. For theta, okay, Anas, thank you. Salma, thank you. For delta theta, is going to be E divided by MC. So the change in temperature here depends on what? Energy transfer over here. Okay. Mass of the material over here. Makes sense. And the specific heat capacity, which give me or depends on the type of material. That's why I asked you to rearrange the equation. So the change of temperature of any substance depends on the, as you see from the mathematical formula, the inner heat energy, the mass, and the specific heat capacity. Okay. I wish you understand this part. We're gonna go back here. This is the equation, change in thermal energy equal mass times the specific heat capacity times delta theta. You know, a change of energy in joule, mass in kilogram, delta theta, and a change in temperature in Celsius. So the specific heat capacity, let me go back to the OneNote file, is specific heat capacity. We can put delta E or E the same. If I ask you to give me the unit of specific heat capacity equal delta E is measured by joule, right? So joule divided by mass is measured by kilogram, and delta theta is measured by Celsius. So the unit of specific heat capacity is joule divided by kilogram multiplied by Celsius. Joule, kilogram, Celsius. Over here, joule, kilogram, Celsius. Okay. So now is your turn. Can you type in the chat what is the definition of specific, keep infrared radiation now. What is the definition of specific heat capacity? What is the definition of thermal conductivity and thermal insulator? So I need to see your answers in the chat, please. Thermal, specific heat capacity, thermal conductivity, and thermal insulator. Just type your what you understood from our lesson so far about the specific heat capacity, thermal energy, and thermal insulator. Type in chat, please. So I need all of you to participate with me. Adham, thank you. I need more specific definition, Adham. Specific heat capacity depends on the types of material, but I need the definition. It's amount of energy needed to blah, 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 blah. I need this one. Yes, Anas, thank you. Thank you. Visan. Okay, thank you. Not absorbed per kilogram, Mahmoud. Specific heat capacity is the amount of energy needed to rise a specific amount of kilogram to specific amount of Celsius, or by a specific amount of Celsius. So I need this definition: the amount of heat needed to rise 1 kilogram of material by 1 Celsius. Okay, Salma, Salma, send your answer in private chat note for everyone. And this is the amount of heat required to raise the temperature. How many Celsius, and for how many kilogram you have to? It's called the specific heat capacity or heat capacity. So you have to specify the amount of energy or amount of heat and the amount of kilogram used. Okay, Nada, you good? Okay, for thermal conductivity. Ahmed Kishta, you are not answering. Jana, Toqa. We need participation, guys. Thermal conductivity. Okay, you good with the thermal conductivity so far? So far, thermal insulator. Okay, Anas. Thank you, Anas. Okay, Adham. Okay, guys. Thank you so much. So let me go back to the infrared radiation. Infrared radiation is a part of electromagnetic spectrum. So what is the electromagnetic spectrum? Let me explain to you first. Okay. I'm teaching astronomy and physics to college students. This is my subject there. So this is the sun, and the sun here is the earth. I just explained this yesterday to the student at college. So the sun emit light, and the light absorbed by we have here atmosphere, atmospheric layers, and here is the air surface. Some of the light absorbed by the air surface. So the light coming from the sun is not the visible light only. The sun emits spectrum of EM radiation, electromagnetic radiation, starting with the very low energy radiation to very high energy radiation, or high energy radiation and low energy radiation. High energy radiation like gamma rays, and very low energy radiation like radio wave. In between, we have many types of electromagnetic radiation. The visible light, the light we are see as a human in this range, in between the very high energy and very low energy. Okay, so infrared is one type of electromagnetic radiation that emit from the sun, and you can have infrared radiation from some of the devices on Earth. But infrared radiation is one type of electromagnetic radiation. I'm gonna show you the electromagnetic spectrum here. You see my Google?
Yes.
Let me take this. Guys, you see my okay, I'm gonna take to OneNote file. No one is answering me.
Yes.
So I'm gonna take it here. Okay. Okay. This is the infrared radiation. So we're gonna start with I said the radio wave is the very short one, and the gamma ray is the very the most energetic radiation. After gamma ray, the one after the gamma ray, more energy means low wavelength. So high energy means low wavelength. Less energy means high wavelength. The wavelength is inversely proportional with the energy. So gamma rays, the more energetic radiation, X-ray, ultraviolet, and then visible, and then infrared. So infrared between visible and microwave, it considered to be low energy and high wavelength. Low energy and high wavelength. So in our definition here, infrared radiation is a part of the electromagnetic spectrum. Okay, we fully understood this. All objects emit or give out and absorb, take in infrared radiation. The higher the temperature of an object, the more infrared radiation it emits in a given time. So if you have an object and you heat the object to a certain amount of temperature, the object will emit infrared radiation. A good absorber of infrared radiation is also a good emitter. So the material or the object that absorb a huge amount of infrared radiation is also emit a huge amount of infrared radiation. For an object at a constant temperature, infrared radiation emitted should be equal to the infrared radiation absorbed. Infrared radiation is emitted across the continuous range of wavelengths. So when the temperature of an object increase, it means the amount of infrared radiation absorbed is higher than the amount of infrared radiation emitted. When the object is at low temperature, the opposite. So we're gonna define now black body radiation. Black body radiation is a theoretical object. This is there is no black body radiation in universe. This is theoretical object that absorb 100% of all radiation that fall on it and doesn't emit any radiation. A perfect black body radiation wouldn't reflect or transmit any radiation and will also be perfect emitters of radiation. So we don't have this ideal case. This is the theoretical value. Radiation and Earth's atmosphere. The temperature of the Earth depends on a lot of factors, like including the rate at which visible light and infrared radiation are reflected, absorbed, and emitted by the Earth's atmosphere and surface. Okay, let me explain here. I just mentioned that the sun emits a lot of radiation to the Earth, right? So the Earth's surface reflect the light again backward or to the atmosphere. Some of the radiation emitted back to the atmosphere. Lower wavelength radiation emitted by the Earth's surface is absorbed by, we have some materials here called, or some gases called greenhouse gases, which is water vapor, carbon dioxide, and methane. So what happened after the absorption of the emitted radiation by these greenhouse gases? The greenhouse gases re-emit the radiation again to the Earth, and this make increase in the temperature. So the greenhouse gas absorb infrared, I'm talking about infrared radiation, a specific type of electromagnetic radiation. So the greenhouse gases absorb infrared radiation emitted by the surface of the Earth and prevent this radiation to escape into space, and then re-emitting the infrared radiation back toward the surface of the Earth, increasing the Earth's temperature. Greenhouse gases is the Earth's atmosphere include water vapor, methane, and carbon dioxide. So our activity as a human activities such as burning fossil fuels, deforestations, and livestock farming, all these factors increases the amount of greenhouse gases in the Earth's atmosphere, and this make the temperature of the Earth increase. So after finishing this, we know the terms of absorb, black body radiation, electromagnetic spectrum, emit, and greenhouse gases. I'm going to ask you to write down the greenhouse gases, please, the definition of greenhouse gases in chat. Just type the definition of greenhouse gases in the chat. Salma, I need the definition. Adham, good. Thank you. Jana, Bisan. Thank you. Okay. Thank you. Jana, Bisan, Nada, and Adham, and Salma. Salma, I need the definition, not the types of material. Guys, please don't search online and give me the answer from Google. I need the answer from your mind. Thank you, Anas. Okay. So now we're done with the second lesson. We're gonna answer some questions. Why does a material thermal conductivity tell you? The material thermal conductivity gives us information about how this material conducts heat. Okay, I'm gonna read an answer to save time. Okay, Ahmed, I got your answer. Which material have low thermal conductivity? The thermal insulators. Give 3 factors that determine the rate of thermal energy transfer through material: thermal conductivity, change in temperature, thickness of the material. What factors affect the rate of heat loss from a building? Thickness, thermal conductivity, and change of temperature. Define a specific heat capacity. We already did this. What is the infrared radiation? We already explained in details the infrared radiation. This is very short definition types of electromagnetic radiation, but we explain it more. What is the relationship between temperature of an object and its emission of infrared radiation? The higher the temperature of an object, the more infrared radiation emitted in a given type. What can you tell about the object that absorb and emit infrared radiation at the same rate? It's constant temperature, or this object at constant temperature. Compare the amount of infrared radiation emitted and absorbed by an object that is increasing in temperature. More infrared radiation absorbed than the emitted. What is the definition of black body radiation? This is a theoretical object that absorbs 100% of the radiation that falls on it and doesn't reflect or transmit any radiation. Name 3 greenhouse gases: water vapor, carbon dioxide, and methane. What human activities increase the level of greenhouse gases released? Deforestation, burning fossils, and livestock farming. Why do greenhouse gases increase the Earth's temperature? Earth's surface absorb and re-emit the radiation from the sun, which greenhouse gases then absorb and then re-emit this radiation back toward the Earth's surface. We done now. This is some of the definition. What is the 1 joule of work? The work when one force cause an object to move 1 meter. Describe the energy transfer when falling apple hit the ground. Energy transfer from kinetic energy store to the thermal energy store. Describe the energy transfer when moving car slows down. So mechanically, from the kinetic energy store of the car to the thermal energy store of the brakes. Describe the energy transfer when electric kettle is used to heat water. We did this last time, but we're gonna say it again. The electric current in the kettle transfer energy to the heating elements of the thermal store. So the energy is transferred by heating from the heating's element through the store to the thermal store of water. Now is the time of mathematical equations. Okay, let me do this with you. Okay. Student uses 12 volt for a heater to heat 1 kilogram metal block. They measure the temperature of the block every minute for 10 minutes. Calculate the work done. So to find the work done, we took from the last time, work equal power times time, right? But we don't have power. We have time, but we don't have power. So the power for the electric heater is equal to the amount of potential difference multiplied by the amount of current. So the power equal VI. If you need to add this formula, the power equal VI. Let me type it down here. P equal VI. V is 12, I is 4, so 12 multiplied by 4 is 48 watt. So I got power. Once I have the amount of power in watt, I'm gonna find the work done, which is power multiple time. Last time we took power equal work divided by time, right? So the work equal power time time. So the amount of power is 48 from the first part, and be careful, the time here is in minutes. You cannot use minutes, you have to change it to seconds. So I multiply it by 60. So 10 minutes is 600 seconds, and then you're gonna multiply the 48 by 600 to have the amount of joule. Okay, this is the first part. Second part, the temperature raise of the plug is 75 Celsius. This is delta theta in the formula, if you remember. Delta theta is 75 Celsius. Calculate the specific heat capacity of the material. Oh, specific. That's why I asked you to rearrange the equation. If you remember here, I asked you to rearrange the equation to keep in your mind. Delta theta, so sorry, specific heat capacity C equal delta E divided by mass multiplied by delta theta. So we need the mass and we need the energy. We need the mass. Energy is the work done, the same. So we need the energy or the work done. It's over here. The mass, we don't have the mass here in the second part. Maybe we have the mass in the first part. Yes, 1 kilogram. Perfect. So the mass is 1 and the change of temperature is 75. You're going to find the specific heat capacity in joule divided by kilogram second. Okay, guys? Now I'm going to give you a question to answer it. This one. To be fully understand the class, you have to answer this right. Block of aluminum has a mass 1.2 kilogram. It is at room temperature, which is 20 Celsius. Student uses a heater to increase the temperature to 50. So if you need to find a change in temperature, you have to make the final temperature minus the initial temperature. Calculate the difference between the initial and final temperature. And then we need the specific, no, we have the specific heat capacity of aluminum. We need the energy. So give you 3 minutes to answer this. I need all of you to participate.
Mister,
I need all of you to participate. You have everything. So we need to find the E. If you need the equation, I'm gonna provide you with the equation. Delta E equal MC delta theta.
Mister,
So find delta theta first and then find delta E. You are working, right? Okay, Anas, the first part is right. Adam, why are you struggling? Nada. No, your answer is incorrect. Mahmoud, your answer is right. MashaAllah. Okay, Adam, I'm gonna explain it to you. Radwa, you good for the first part? Bisan, no. Bisan, you get the temperature right, but the change in the energy is not correct. Nada, no, try again. Try again. Selma, you good? Give me the final answer, please. Anas, you good, mashallah? Anas and Selma, you good? Try again, guys. I already gave you the formula. Selma, you good? Radwa, you good? MashaAllah. Jana. Lisan, can you try again? Jana said confused about the E part. Okay, I'm gonna explain to you right now. Nada is not 36. Okay, guys, I'm gonna explain it to you. Okay, do you have problem with the change in temperature? Change of temperature is the final value minus the initial value. It's gonna be 50 delta theta over here. It's gonna be 50 minus 20. So the answer is 30 Celsius. You have problem with this part? Ahmed Kamal, you good, mashallah. So this is gonna be 30. The specific heat capacity is over here. So the energy, I said delta E equal MC d theta. So what is the value of M? 1.2, right? What is the value of C? The value of C is 900, right? What is the value of delta theta? 30. And it's the same. It depends on the reference. Some reference using Q. Anas is asking, isn't the heat energy representing the letter Q instead of E according to the reference? Q or E. At college, I'm using Q.
زي اللي بيعملوا دوت.
But here from this reference,
طبعا
they are
عارف
using
اللي
E.
خدت
It's okay.
الكتب اللي هو منزلها. نعم يخلص.
So when you multiply M, which is 1.2 by C, which is 900 by delta theta, which is 30, you're gonna find the answer is 20.
فاكر لما كنت
here 20. No, 32,400. Don't forget the unit a joule. Nada and Bisan, you got it?
عملت لك امتحانات
Okay. You know what is the mistake? Okay, guys. A student does this experiment.
وشغال بقاله قد ايه؟
A student does this experiment and finds the energy that needed to transfer is bigger than the energy calculated in 1.2.
ده بقى صح.
You know why?
اصحى بقى يا ماما اصحى بقى ونتكلم في على بعض.
This is like open question. Imagine why we have more energy than the calculated energy.
فاكر الجنسية بتاعت منا؟
So we have some additional energy added to this system from the background.
والله هو هذا فيه وقال
maybe infrared energy, infrared radiation.
في الانديكيشن بتاعه وجات لها عملت ايه؟ من في حد يجي لها اللوتري بتاع امريكا وتسيبه. انا سكت والله انا سكت.
Yeah, this is lower. Yeah.
كل دي يعملوا لها ميديكيشن كورونا دي مش عايزه ترد على.
I muted Tariq. Okay, guys, sorry. So we have some energy amount of energy loss to the surrounding. This is the reason of the energy they need to transfer is bigger than the energy calculated, because maybe some of the energy loss to the system. Okay, we need to answer another question if we have one here. Okay, let me explain the last one again, and it's enough for today. What is the last question you asked about the, yes, this one. A student does this experiment and find that the energy they need to transfer this is the true energy is bigger than the energy calculated. So we need to add some energy here to the calculated energy. Do you know why? Because maybe some energy need to add it because of the some energy lost to the surrounding, or because we already have some energy coming from the background that make the experimental value less than the true value. Okay. Okay, guys. We good for today? Can you answer this question at home? And if you have any problem, let me know. Next time, inshallah, we gonna, where is that? Next time, inshallah, we're gonna take P3 national and global energy resources. Okay. Inshallah, next week at 4 p.m. Cairo time.
Sir,
Have SAP with me, you can wait in the same Zoom link. Assalamu alaikum, guys.
Sir, is this class AQA or Cambridge? Sir.
Oh, I have to turn off the exit the Zoom link to stop the recording of the physics session and open again for the math session. So you can use the same link after a few minutes, okay? Assalamu alaikum.
Sir, you can just stop the recording.
Sir.
Okay, Radu, I'm gonna send it to you.